Hi, so I have a few things to show that I've been working on the last, I don't know, maybe couple of weeks now. So the most exciting thing I've been working on is a real-time shader editor. So this was the most recent thing that I've done, but it came about when I was trying to edit to create some lighting shaders. It was really annoying to have to edit the shader, compile it, then run the engine and set up a scene to view it and stuff. So I thought, oh, it would be so much easier if I could edit it in real time and see the changes exactly when I save it when it's been edited. So that's what I've created here. So this window is a new scene. It's different from the scene in the back. Um, and you choose your shader editor using the file explorer that I created. It's created by this button. We can create another one. Um, and yeah, so this updates because I've chosen the f underscore model and v underscore model for fragment and no, the vertex and fragment shaders. So if I change these, it will now update. So if I change this to a vector 4, and we just give this some default values, you can see now it's white because I've said that every fragment should be a white color, and we can change this. It's now a cyan color. So yeah, this is really useful for editing shaders in real time and seeing what the results are without having to go through that laborious process of restarting the application every time, having to manually compile it like I was, or at least with a Python script anyway. So yeah, this updates only when you save the file. There's a few things missing. When it compiles it, it doesn't show the errors. It'll in the console it will have some lines in that like it can't find the file if it's not compiled properly. But this won't change. It will just stay to the same as we had before. But yeah, I want to have like a separate console on here that will give out the compiler error, not just like the random, oh, I couldn't find the file because it didn't compile correctly. So so yeah, I'll jump into the code and show a few of what some of the stuff that I've changed. Okay, so this is the class for the shader window, the shader editor window. In the constructor here, I really shouldn't be doing this. It should be done in a like lazily, I guess. So when I actually need it, but I load the model, add it to an entity in a scene, and that will be my new scene that I pass to my scene renderer. So this is kind of essentially where everything happens. I should say don't copy this kind of code. I threw this together because I wanted to get it working quite quickly, just like as a proof of concept or how will it work or whatever. But really, I want to separate everything into the window, like this is editor window. So the window files will only have the I'm GUI stuff related in, and all of like this kind of stuff where I'm refreshing a file info. And then testing its write time with the last write time. That really should be in a different class because it's a different responsibility. But yeah, I'm going to refactor some of this code. I just wanted to get something working first and then refactor it. But I haven't gone all out, like I have a shader compiler, which is actually a different dependency. So essentially, we have this file picker, which is the section. It draws the file dialog. I pass in a function, hashtag functional programming. But yeah, I get the write time. I minus 1 second from it just because the first time it comes around, these will be null, and I want it to like Sorry, the info won't be null, but I want it to compile the shader the first time it comes around, because I'm not going to assume that the shader's already been compiled one time before. So yeah, it's like, okay, the last read time is different. It compiles the shader, which is essentially this process. So we get a shader C path from our path static string. We give it some variables, some arguments. It's just input and output files. Also the shader type, so whether it's a vertex or a fragment shader. We try and compile it. In here, I need to actually get the errors that come out of the compiler. But yeah, so if it compiles successfully, returns the shader in the out parameter, and returns true. I did this because structs can't be null, so I would either give out an empty shader or like a default shader, and I don't think it's very obvious, so I put in a try compile. Yeah, and if it can't compile it, then we get an exception, and that was essentially the can't find file exception message that you saw in the logged. So yeah, that's pretty much it. After it compiles it, we make a new program because this needs to be created every frame. This false means do not destroy the shaders when we dispose of the program, which we do every frame because we want to update the shaders or the shader program every time they change. So yeah, there might be a way that we don't need to destroy it every frame, only when this changes or one of these changes, but whatever. I have a to-do here to make this more efficient, so I think I'll refactor and then make it efficient, because preemptive optimization is notorious for being annoying or obfuscating what you're trying to accomplish or making it harder to accomplish that goal in the first place. So yeah, that's the real-time shader editor. One of the other things I spent some time on was an asset window. So there is a few problems with this out the bat. The version of I'mGUI that I'm using, specifically the bindings, the double click does not seem to be working, so it doesn't work exactly how I want it to work. But it's good enough for now. I'm not going to spend any more time on it because it was just like a quick thing that I wanted to get in. So essentially we have a breadcrumbs up here that let us navigate. You can click on the files and stuff. We have at the bottom here we have the last thing you hovered on, it will show you the full name of that thing, so because they're too long to display underneath. It scales very well. If we pull this out, you can see that it scales sideways and vertically, so yeah, that's nice. We have these tree nodes or leaves. There is a bug where if you click on this top one, so if we go into meshes, click on assets, it doesn't take us back. If we click on textures, it does. That's annoying. I don't know what the issue there is, but it's something that I'll have to fix. And the way I was going to go about it was you'd open by only clicking on the arrow. You can't open it otherwise. And then double click to open the file, the folder even. But because double click isn't working for some reason, I had to just forego that. But yeah, other than that, this is all working, and we'll have the plan is when you double click on these files, if it's like this is a CS file, so hopefully it would open Visual Studio or Code or whatever your default is. If not, it would open, like, say if it was a shader, it might open that shader editor window that I showed you earlier. So yeah, that's the. Oh, I'll show you the code for it because it's actually quite clean and stuff. I enjoyed making it a lot. I'mGUI is so fun to use. So okay, so this is the code for the asset window, and I was surprised like how easy it was to make actually. Really felt really concise. So we have all of our I'mGUI stuff in here. breadcrumbs, the folder structure. So this is what I thought was really fun. So draw a folder structure. Oh, sorry, this is the tree on the side, which is not what I wanted to do. It was the draw item. So yeah, sorry, the file area. So we have this file area. It's just got a given size. So draw items. This was cool. So we have one private method here for drawing the items, which uses a file explorer, which is a new class that I made. Essentially, just has a location, and it gets when this location is changed. So on location set update. So when it's updated, clears the folder and the file things. I'm just thinking, actually. Sorry, I'll explain that in a minute. So it clears the folders in a file, and then for each file, it enumerates, essentially gets all the folders in the file. You know, you understand. So yeah, this is a really small class, but really powerful, right? So sorry, not that. So when we go into here and we draw the items, we just get the folders to list. Okay, so this is what I was going to explain. To list, we have to list it because if we change the location, which we will do because they're buttons, so when we go through and iterate over these and we change the location, it will wipe the folders list. So if we didn't create a to list, it would throw a, I can't remember, some exception like argument out of range because we edited the collection while we were enumerating over it. So actually in this file explorer, this .get should be .to, to lists or something in here. I guess because I've put it as a read only, but yeah, I should really .to list these because then I wouldn't have to rely on the user to list them. So yeah, we figured that out just now. It's kind of stupid to have people understand that you need to do this, otherwise it will probably break. Oh, maybe it's not. Maybe if they don't actually need to change it in the loop, then don't. But it is read only, so you're not meant to be able to edit it. So maybe if we, yeah, whatever. I'm rambling again. So this was cool because we have the draw items, which does all the setting of the cursor. The draw item does the hover stuff, calculates the size of the text, and draws the text. And we can use the same thing for both the folders and the files, right? So that was really cool. We pass in a function, hashtag functions as first class citizens. So pass in a function that will do an action on that button because they're all buttons. So you can have whatever here. I just changed the location. This is what led me to discovering the collection edited problem that I didn't see beforehand because I wasn't to listing this. But anyway, I thought that was pretty cool. Okay, so last but not least is I started working on the lighting shader. So this is very hacked in at the moment. In the shader itself, I just have like a static light location. So in my scene, you can see that I don't actually have a light in the scene. That's because it's just written in the shader. But yeah, we have the start of the lighting, and I was gonna pass in. I was setting up the code to pass in a light from the scene or multiple lights when I ran into the idea of this is going to be very inefficient, right? Because we're going to compute the light for every light in the scene, which is called forward rendering, right? Which was kind of like the standard de facto rendering technique. Obviously, people had these problems. What they did was they set limits on lights or whatever to kind of combat that. And then somebody, I don't know who, but somebody came up with deferred rendering, where you render all of your geometry, your color, your depth data into textures, and then you sample those textures in the fragment shader when you're calculating your lights. So forward rendering on its own has like number of lights times number of fragments in complexity, right? So you could imagine how, like, yeah, I don't know how many fragments this bunny has, but thousands of fragments just on one object. So if you imagine thousands of lights in the scene, yes, you wouldn't need thousands of lights if you only had a bunny, but the computational expense on that is going to be massive, right? So deferred rendering has a computational expense of screen resolution or window resolution times the amount of lights that you want to render, which is great because, like, this viewport, for example, this size of this viewport pixels is small, so could add loads of light and it would only ramp up quite slowly, right? But you will get to a point where you still have too many lights and you have performance hindrance. Also, with rendering, with deferred rendering, anything, you can only use one shader for everything in the scene. If you have something that requires a different shader, which nowadays, like, a lot of things have dedicated shaders for, but like if I was going to render the light and I had, okay, the light isn't affected by the lights, right? I can't render that with the shader that I'm rendering everything else in the scene with, so it doesn't work with deferred rendering. So what people do is they render with deferred first, keep the depth buffer, and then render with forward rendering, standard forward, well, just a form of forward rendering, right, afterwards. And then because you've kept your depth buffer data from the first rendering pass, everything looks right. So there's two ways of combating that. There's now this technique called forward plus shading, which is used. This is back to the idea of doing everything. So everything can have its own shader or whatever, and you render forward, but it breaks down lighting or different calculations differently. So whereas we did all the geometry and then all the lighting, what we do is we break down all of the pixels or the frustum into tiles. So it's called forward rendering plus or tile rendering. Forward rendering plus kind of encapsulates like volume tile rendering and some other different processes of grouping the lights. But essentially what it is you break down the screen into tiles, and then the lights that interact with those individual tiles you group and only do forward rendering on those group of lights. So as long as your lights aren't all in the same place, or all the lights are huge so they encapsulate every tile all the time, you'll only have the lights that interact with your thing to deal with, and it will keep the complexity quite low, right? So that means for the complexity is per tile. So it would be fragments in that tile plus, or times by the lights in that tile. So even though the complexity technically is the same as forward rendering, if all the lights touch all the tiles, it's exactly the same. Otherwise, it's a lot lower, so you can get away with more lights. Yeah, so I'm going to try and implement almost all of these ideas. Like I want to have forward rendering just by default, I think. The ability to have deferred rendering. The downside with deferred rendering is that it takes up a lot of bandwidth and memory on the GPU, which maybe isn't acceptable for mobile games and stuff where you have limited hardware. So, and also, obviously, tile rendering would be great to have in because then I don't have to care about lights and complexity and stuff. Yeah, with tile rendering, the bottleneck really comes down to the sorting of the lights rather than anything. So yeah, that's cool. I learned so much researching this. I'll link some videos in the description that I watched that were really informative, and like I found out that on the GPU, if you have an if statement in your shader, as long as one core needs to go through the if statement, all the cores will wait on that one core to finish going through the if statement, or essentially as if they've all gone through the if statement. So very interesting that you really should just avoid if statements at all costs in your GPU, or just literally do the bare minimum that you have to do. So yeah, very interesting. But I think that's all for now. I look forward to seeing you in the future with some cool new stuff. So thanks for watching.